Good morning. Welcome to the Lab of Wireless Communication of IMDEA Networks, in which we develop not only wireless communication, but also energy-efficient communication, by the way. Today, I'll show you a few of the groups that are working in this lab, not all of them. And we will show the work that has been done in the last few months, and the work that we are doing for European projects and other projects, active national, regional, European projects, plus what we are planning to do for the next future. I will give the floor to the students to introduce what they are doing or what they've done, but just let me introduce a few key concepts that we are developing in this place, this lab. We work on applications, we work on protocols for wireless communications, and on the evaluation of the energy efficiency of these protocols and applications. The details will be soon explained by the students. IMDEA is an international research center. Here we have an example of an international group with a Greek guy, Angelos, and the Spanish one, Jordi. They work on the energy efficiency of the PCs that we use every day for research. So they will explain in a few words what they are doing and the results that have been found so far.
At this part of the lab, we perform measurements on the power consumption of the different components of servers. For instance, the memory, the disk, the processor, or the network. On this device here, this is a power analyzer. We keep track of the instantaneous power consumption, and we further record all the values on this laptop. Given the total log that we keep track, we can extract the energy required by every task. Our tasks require multiple servers to be performed faster. Moreover, by these logs, we can generate analytical models, and we generate, in the end, those kinds of graphs that gives us the most efficient operation using different frequency and voltage levels.
So basically, with this kind of results that we find in our logs, in our results, we can find the efficiency of the different configurations we have in our machines. Because usually when you get a machine, it has some automatically or some self-configured things that might be improved. So with these results, what we see is which of them are more efficient than the others, and how can we improve the future algorithms so the energy consumption of those servers are better. So that's important because basically the most efficient, the less power we consume, the most money we save.
So we study and design protocols and mechanisms for wireless networks, cellular networks, for instance. And in this corner of the lab, we prototype part of the ideas that have been studied, in particular in the framework of a European project which is going on, and it's called CROWD. It's an FP7 European project.
In this part of the lab, we emulate the LTE networks. In particular, we have two NI-PXI. One of them are for the base station, while the other one is for user equipment. In this example, we can see how we can emulate the channel. In this case, we have a fixed line in order to emulate this channel, and then we can turn this line in order to get different results for our simulation. Then on top of this, we have NS3 Lena, where we can develop our algorithms. In particular, we develop algorithms about inter-cell interference coordination and user associations.
In this poster, we can see the architecture of the testbed of the European project CROWD, where IMDEA network is involved. As you can see, our platform can be divided in two different parts. The blue one is the part where we emulate the real physical channel and is emulated through an NI-PXI equipment. The white one instead represents the LTE MAC that we emulated through Lena, NS3 simulator. On top of this platform, actually, we can evaluate any possible application. Our testbed is really modular, so we can evaluate different algorithms that is typically the output of our research.
We develop applications for smartphones that can be used to evaluate and to test in the real world the research, the theoretical research that we perform. So in particular now, Shahzad will present some applications, in particular one version of one application he developed for Android smartphones that is used for the so-called context-aware floating content service.
Applications that adapt themselves according to environment are referred to as context-aware applications, and location is one of the most commonly used type of context. Such applications have communication requirements that are quite different from ordinary applications, and opportunistic communications can play a special role for such applications. In our research, we consider a specific communication service called as floating content, which is based on pure ad hoc communications, and it aims at ensuring a piece of content within a certain geographically restricted area. So we developed an Android-based application for performance evaluation of floating content. So we implemented floating content on smartphones and did the performance evaluation. This is Floaty app, which is an Android-based application that we developed for the performance evaluation of floating content. It implements floating content, and for localization, it uses the access points of the building, and it scans for the access points, and if it finds one of the access points that is in the list, it assumes that it is within the building. So suppose that a new user enters inside the building and it runs the application. It asks for Bluetooth discoverability. Once you turn on the Bluetooth, first of all, it scans for the Wi-Fi access points, and if it finds one of the access points in the list, it assumes that it is inside the building, and it starts exchanging content with all the devices that are running the same application. For example, in this case, this device connects with this device and exchange all the contents that are to be floated within the building.
Part of our activities consist in developing protocols and mechanisms to ameliorate the performances of Wi-Fi networks for future implementation of new services, commercial services. So we do implementation on real devices that now will be introduced by Giulia, who is a student from Politecnico Milan, a university in Italy, who is visiting us for her internship.
In this project, we implement opportunistic method for relay of the packets. We have 4 different machines that are Alex board, and we implement 2 different connections. There is Wi-Fi in the left part and Wi-Fi direct in the right part. In Wi-Fi direct, we can have device-to-device communication, and one device can be connected to multiple machines. This makes possible the relay of the packets through different machines. With the opportunistic method, is it possible to send information about the channel quality of these 2 machines in the middle, and they are sending the value to the access point. The access point is connected to internet and is continually analyzing the values of the channel. Comparing the 2 values of the channel is possible to send packets through the best channel that they have. So in this topology, the computer is connected to the last machine and is asking for the content, that is a video in this case, to this machine that is connected to internet. So we can see a video from there through internet. We can show how the opportunistic method works running this simple test here. With the test, this machine, the access point, is evaluating the values of the 2 different quality of the channels. Evaluating the channels, he's comparing the 2 values and is modifying also his routing table. With this method, it's possible to send packets in a dynamic way And also, if an antenna, if we remove an antenna or the quality of the channel is not so good, we can send packets through the other machine to the end of the topology. So we can see a video on the last part of the topology through internet because it's reaching packets through the access point that is connected to internet. And here we can see that the access point is continuing evaluating the values of the channel, changing topology.